So let's look at a more general redundancy-based approach, which is the n-module redundancy. For n equals 2, we have already seen a brief example of that. We call this dual module redundancy, and we have seen that it can guarantee detection, but not also correction of one fault, or one faulty module for that matter. Note that we can detect sometimes more than one fault as long as these faults are in the same module, or as long as they're affecting different results of the modules. But all we can guarantee really is that a single fault will be detected, and we cannot guarantee its correction because really this technique doesn't correct anything. N equals 3 gives us what's called triple module redundancy, and it allows us to correct any one fault or even all faults produced by a single faulty module. Again, sometimes we can tolerate more than one faulty module if the two faults in the different modules don't affect the same result, but all we can really guarantee as far as the number of faults we can correct is that all faults that occur within the same module will be corrected. And that's because the other two modules are functioning correctly, and their correct outputs are going to outvote whatever the faulty one is producing. We also have examples when n is equal 5, and that would be called 5-module redundancy. A good example for that is the space shuttle. It has 5 computers that are doing the same thing, and then they vote. If we get one wrong result in a vote, we just continue normal operation of the space shuttle. If we get 2 wrong results in a vote, the mission would be aborted, but there is still no failure because the 3 correct wrong results are still outvoting the 2 bad ones. We are aborting our mission because if another module fails and now we have 3 wrong results in our vote, we can no longer correct that and we can get the bye-bye space shuttle scenario. So the idea is if we got one vote wrong, we know we can tolerate more than that without any problems, so we will just continue normal operation. These missions are expensive, so really if there is a single failure, we want to be able to continue normally. Another one happening after the first computer has had a problem is a very rare occurrence, and we would abort the mission because now we have some time to safely land the space shuttle while we still have 3 functioning modules. If it ever gets to another one failing after that, we can no longer promise that things will be correct, and at that point we are risking the astronauts' lives and possibly some people on Earth too. So that's why the mission gets aborted before this happens.